Hey everyone, and welcome to This Explainer. Today, we're tackling a massive question in the world of AI, which is how do we actually know if an AI is smart or if it's, just really good at guessing? There is this entire rigorous grading system behind the scenes, and honestly, understanding it completely changes how you'll view the tech in your everyday life. Let's get into it. So, think about this for a second. The stakes for getting this right are absolutely massive. We're not just talking about some algorithm recommending a cheesy movie for your Friday night. No, we're talking about deploying untested AI in literal life-or-death scenarios. Imagine a self-driving car trying to navigate a crazy busy intersection, or an AI analyzing a patient's X-ray for a critical medical diagnosis. If that AI is just randomly guessing behind a curtain of complex code, the consequences would literally be disastrous. We need absolute certainty. And that deep need for certainty brings us right to our core concept today, which is model evaluation. Simply put, this is the process of measuring the performance and correctness of an AI model. You can kind of think of this as the ultimate, hyper-rigorous exam that an AI absolutely has to pass before it's allowed to enter the real world. It's exactly how developers ensure a model is accurate, reliable, and actually ready for deployment. Because without this critical step, we'd essentially be flying blind. To break this all down, here's our roadmap. We'll start with why we test AI, then look at the 4 possible outcomes, break down the confusion matrix, expose the accuracy illusion, compare precision versus recall, and finally, look at the whole AI project cycle. Okay, section 1, the 4 outcomes, getting it right or getting it very wrong. Before we dive into the heavy terminology here, I want you to keep this super simple anchor in mind. It's a great memory trick. True just means the AI's prediction is correct, and false means the AI's prediction is wrong. That's literally it. True equals correct, false equals wrong. If you lock that into your brain right now, everything else we talk about is going to fall perfectly into place. All right, let's look at the 2 best-case scenarios first, the ones where the AI actually gets it right. First up, we have a true positive. Imagine a medical test. The patient actually has a specific disease, and the AI correctly predicts that they have it. It's a true prediction, and the outcome is positive for the condition. Awesome. Then we have a true negative. Here, the patient is healthy, and the AI correctly predicts they're healthy. Both of these are massive wins because the AI's prediction perfectly matches reality. But what happens when the AI gets it wrong? Well, these are our false outcomes. First is a false positive, also known as a type 1 error. This is when the AI wrongly predicts a completely healthy person has a disease. Obviously, that's really scary for the patient, but usually follow-up tests are going to catch that mistake. But now look at the other side, the false negative, or type 2 error. This one is incredibly dangerous. This is when the AI wrongly predicts a sick patient is healthy. The AI completely misses the disease and that patient goes home untreated. In the medical world, a false negative like that can be absolutely catastrophic. Moving right along to section 2, the confusion matrix, and how we actually structure these outcomes. So, a confusion matrix is a tool that, ironically, completely clears up the confusion. It's essentially a 2x2 grid that compares actual values against predicted values. And what's really cool is how the correct predictions, your true positives and true negatives, align perfectly on one diagonal across the table. Those are the AI's big success stories. The mistakes, though, the false positives and those really dangerous false negatives we just talked about, well, they fall on the opposite diagonal. By just glancing at this grid, developers can instantly see exactly where and exactly how often the AI is making errors. Let's jump into section 3, the accuracy illusion. This is all about when being right is actually completely wrong. 99%. Just imagine, for a second, an AI model built to predict which students are going to pass or fail a really difficult exam, and it scores a staggering 99% accuracy. I mean, in almost any other context in life, a 99 out of 100 is an absolute A+, right? You'd think this AI is a total genius, ready to be rolled out to every single school in the country. It sounds like this massive, undeniable success story. Now, what's really interesting here is the massive plot twist hiding in this data. Let's say out of 1,000 students, 990 of them actually passed the exam and only 10 failed. How did our so-called genius AI get that 99% accuracy? Well, actually, scratch that genius label, because it just blindly guessed that everyone passed. By simply predicting pass for every single student across the board, it got 990 predictions right, which technically gives it 99% accuracy, but it completely failed to identify the 10 students who actually struggled and needed help. The AI didn't learn a single thing. It literally just played the odds. So in this case, that high accuracy completely masked a terrible, totally useless model. Which brings us to section 4, precision versus recall, and how we fix this whole accuracy trap. Because high accuracy can be such a dangerous trap, we need advanced metrics to truly understand the model's behavior. First up, precision. Precision asks a very specific question. Out of all the times the AI claimed the result was positive, how many times was it actually right? It's all about the quality of those positive predictions. Now, recall is a bit different. Recall asks, out of all the actual positive cases that existed out there in reality, how many did the model correctly find? To put it simply, precision is about not crying wolf, while recall is about making sure you don't let a single wolf slip past you. And this brilliantly illustrates how those metrics apply in the real world. Take spam detection, for example. You absolutely need high precision here. You definitely don't want the AI aggressively flagging everything as spam and accidentally tossing a super crucial work email into your junk folder. But flip over to medical diagnosis. Here, you need high recall. If a patient is sick, you absolutely must find them. A false positive, like asking a healthy patient to just take another test, is, mildly annoying. But a false negative, missing a deadly disease entirely, is tragic. The real-world stakes completely dictate the math that we have to prioritize. So the crucial point is that context is absolutely everything here. Accuracy gives us overall correctness, precision tells us the reliability of our positive predictions, and recall shows our ability to identify every single true case. You really can't just look at one of these numbers in a vacuum. You always have to ask yourself, what exact problem are we actually trying to solve? Because that specific real-world problem is exactly what determines which metric is the most important for evaluating if an AI is successful. All right, finally, section 5, the AI project cycle, the final gatekeeper. Let's zoom out for a second and see how this all builds across the entire development cycle. Step 1 is training the AI model with just massive amounts of data. But before it ever reaches you and me in step 4, it hits step 2, evaluating models. And this is exactly what we've been talking about today. Based on things like the confusion matrix, precision, and recall, developers almost always have to circle back to step 3, improving the model. Evaluating is the ultimate non-negotiable gatekeeper here. An AI doesn't just get deployed because it learned some data, it gets deployed because it actually passed the evaluation. Which leaves us with this final thought. AI isn't just science fiction anymore, right? It's recommending our movies, it's filtering our emails, it's driving our cars, and it's even diagnosing our health. So the next time an AI makes a recommendation for you, are you going to just blindly trust its accuracy, or will you ask the deeper questions about its precision and its recall? Thanks so much for joining me on this explainer. Keep questioning the incredible tech around you, and I'll see you next time.